All right, so 4.8, this is our last section in chapter 4. We're going to talk about the mean value theorem and then more specifically Rolle's theorem. So Rolle's theorem states that on any closed interval, if you're differentiable on the open interval, which means a smooth, continuous curve, no cusps, points, corners, then you have at least one point in that interval where the situation occurs. Keep in mind, that has to be true. Your endpoints have to have a function value of 0. So Rolle's theorem is very, very specific, and it says that f of a has to be equal to f of b, and that has to be equal to 0, which means those are x-intercepts. Okay? So find the two x-intercepts of the function, x squared minus 5x plus 4, algebra 1, and confirm that f prime of c equals 0 at some point between those intercepts. So we're going to go ahead and factor this, favorite F word ever, factor, and we're going to get our x-intercepts of 1 and 4. Okay. Mr. Burkett's awesome. Okay, so now we need to take the derivative. So let's f prime this, and we're going to get 2x minus 5. Setting that equal to 0, we're going to get x equals 5 halves. Well, 2.5 is clearly in between 1 and 4, and therefore that's the point at which it's 0. Amazingly enough, with a quadratic, that's always at the vertex. Hint, hint, hint. Example 2. Okay, differentiability requirement. That just means you can take the derivative. Okay, differentiability just means you can take the derivative. In Rolle's theorem is critical. If you are not differentiable, by the way, we talked about differentiability back in chapter 1. If it is not differentiable, then you cannot use Rolle's theorem for the conclusion, i.e., there you go. You've got a corner, a cusp. Keep in mind, this is an absolute value function, which back in pre-calc, back in algebra 2, we had to write as a piecewise function, okay? So that's very important that you make sure that the first theorem is correct, okay? The first premise. So it has to be differentiable. If it's not, you cannot use it. Okay, so example 3, if we satisfy the mean value theorem on the closed interval, then we're guaranteed at least 1 point. It doesn't mean we're not guaranteed more than that, okay? But the minimum is a guarantee of 1, at least 1. We can have more, but we're guaranteed only 1, okay? So sine x is continuous and differentiable everywhere. So the hypothesis satisfies that on the interval 0 to 2 pi, the endpoints are 0. We're using the sine curve from pre-calc. And if you look at the picture, or you can do this on your graphing calculator as well, you can graph sine x or sine theta, and you can see that, in fact, there are 2 places where you have a horizontal tangent, and that should be at your max and your min for the sine curve. Okay. So the mean value theorem. The mean value theorem actually goes one step further than Rolle's theorem. Okay. So Rolle's theorem is saying that if you had 2 x-intercepts, they were both 0. Okay. Let's take a look at this. Connecting these dots, what kind of slope does this line have?
0.
Good answer, Mr. Burkett. It's a good thing he's passed calculus. Great man here. So the mean value theorem simply says that if you know what the secant slope is between 2 points, then at least 1 point in that interval between A and B, you had to have a slope, tangent slope, that is exactly equal to your secant slope, okay? And so the way we do that is we set our derivative equal to the secant slope. FYI, quick refresher, we did secant slope back in chapter 1. Before that, you actually did this in algebra 1. For some of you, pre-algebra, that's just the slope between 2 points, okay? But you need to use the endpoints. So let's do an example and see what happens. Show that the function 1/4 x cubed plus 1 satisfies the mean value theorem hypothesis over the interval 0 to 2 and find all values of c in the interval 0 to 2, not inclusive, at which the tangent line is parallel to the secant line. Okay, so 0 to 2. So what I want to do then is find f of 0, which means plug in 0, and I get 5/4. No, Miss Collins, you idiot. Yeah, she just said that. 0 times anything is what? Mr. Burkett's here to keep me on the straight and narrow. And 1/4. Hey, this is going to be the best video ever. So, 8 divided by 4 is 2, and 2 plus 1 is 3. Okay, so Mr. Clinton's class is going to love this. So we have our ordered pairs, 0, 1, and 2, 3. Now I'm all giddy. All right, the slope between these lines, 3 minus 1 over 2 minus 0 is 2 over 2, which is 1. Okay, so now what we're going to do is we're going to complete the second part, which says f prime of x is equal to 3/4 x squared. And now what we're going to do is we're going to take that derivative and we're going to set it equal to 1. So 3/4 x squared is 1. So x squared is equal to 4/3. So x is either plus or minus 2 over the square root of 3. And no, we do not have to rationalize, so please leave it alone. Now, my answer here is x is equal to plus or minus 2 over root 3, but I was very specifically told in the interval 0 to 2, which means the negative number has to be thrown out, and the c, the number, the constant value that we're looking for, is actually the x that we found of 2 over the square root of 3. Okay, so c, the c they're talking about, the constant that makes the intermediate value theorem work, is actually our x, and we get it as 2 root 3. Okay. All right, so now if we use the velocity and we relate this back to section 4.6, you're driving on a straight highway in which the speed limit is 55 miles per hour. At 8:05, a police car clocks your velocity at 50 miles per hour. At 8:10, a second police car posted 5 miles down the road. So here's your hot rod. And you're at this marker, and you're clocked at 55 miles per hour. Silly. Miles per hour. And that's at 8:05. And then 10 minutes later, your hot rod, which evidently is bigger than it used to be, you're clocked at 50 miles per hour. And that's at 8:10. So we've really only lapsed 5 minutes, which there's 60 minutes in 1 hour. So the portion of an hour that 5 minutes is 1/12 of an hour. We're going to need that. And so then explain why the police have the right to charge you with a speeding violation. All right, well, let's find your average miles per hour for the amount of time that you were going between these two. So here you were 55, here you were 50, and the speed limit's 55. Oh, Miss Collins, you wrote them in the backwards order. This is 50 and this is 55. And now why can they give me a ticket? Well, let's look at my average over that amount of time. So over that 5 minutes, what was my average speed? So if we say at 0, I was going 55 miles an hour, and 5 minutes later, or 1/12 of an hour later, I was going 50 miles per hour. I can find the average rate of change. So I'm going to come over here, 55 minus 50 over 0 minus 1/12. Oh, that's going to give me my acceleration.
Correct.
So I was slowing down.
5 miles down the road.
Oh, Mr. Burkett, thank God you're here. 5 miles down the road. Good Lord, you are so lucky Mr. Burkett is in this room right now. So, in 5 miles, that's the distance I traveled. 5 miles down the road, and I traveled that distance in 1/12 of an hour. Thank you, Mr. Burkett. Then technically my average speed is 60 miles per hour. Ooh.
Left foot.
Yay! Thank God Mr. Burkett was in this room. So I wrote down a lot of information that didn't really matter. I was one step ahead of myself. This is all information that would have helped me with my average acceleration, which I am not being asked for. I'm being asked for something having to do with my speed, which I'm hoping you all relate to velocity. Okay, so my average speed then would have been 60 miles per hour over that time. That's a bigger deal. Okay, quick check exercise, page 307 in your textbook. What you're going to do is utilize the mean value theorem predominantly, Rolle's theorem, which in fact is a specific example for the mean value theorem. And remember, whenever you're talking about this C, the values of C, the values of C, the values of C, the values of C. Remember, we're actually talking about the X values if we have a function, okay? We're talking about the number C that would be the input, the X, that's our input. Okay, so you're going to complete those quick check exercises, and then for Mr. Clinton's class, the answers are on page 310, and you should have those ready tomorrow before he gives you the assignment. For my little cherubs, you need to have that ready for Monday when I come back. All right, that is it.